So once again, my name is John Fellenstein. This is Dr. Ruel McKenzie. We work at the University of Akron, and we are back for another Science Friday. Are you excited about that? Yep. So we're excited too because guess what today is? Today is the winter solstice. Oh yeah, you know what that means, right? So we're going to do some really cold things today. Some cool things, but some cold things as well. And we're going to be experimenting with some items that normally you don't come into contact in your everyday lives. Okay, so we're going to use some carbon, some dry ice, which is also solid carbon dioxide. Okay, and we're also going to do some activities with liquid nitrogen. So hopefully we're going to maybe be able to recreate a couple of the scenes from the movie Frozen here. And I heard that Coach Cruz also might want to sing a few bars from some of those songs, okay? So. Now I know that is something that you will never, ever forget, right? Okay, cool. All righty. So what we're going to start off with is I want to show you what the dry ice looks like. We have to keep it in a cooler, all right? Normally we keep other things cold in a cooler like this, but so we have a service at the university that will give us these little, they're like these little pellets, okay? And they're made in an industrial machine, all right? So basically what they're doing is they're taking air and making it so cold that it turns into a liquid, and then there's another process which extracts the carbon dioxide from it, okay? And dry ice is really an interesting material because, you know, why do you think they call it dry? Why is it called dry ice? Any ideas? What do you think?
Because it's not wet.
It's not wet, exactly. So it's cool. It goes from a solid, okay? It goes from a solid to a gas, and it never turns into that liquid stage. Like, you know how when you melt an ice cube and it just turns into water? This never does that. It goes from a solid to a gas, okay? Okay? So it's cool. You could get frostbite if you're not careful. All right? So the first thing we're going to do is I need a couple of volunteers to come up here, Coach. Grab a pair of safety glasses and then put on those gloves. Okay? We've set a nice table over here for the girls. Get this out of the way. Okay, now, since dry ice is so cold, what we're going to do is we're actually going to have, now these are out of my kitchen, so you have to be careful with these, okay? Do you promise to do that? All right. I don't want you to eat it, but I want you to take the spoon and I want you to press it down onto the dry ice, okay? And tell me if you notice anything. Maybe we can bring the microphone over here too. The other mic. Go ahead, you can go ahead and start. There's a plate for each of you. So just maybe use your gloved hand to kind of hold it in place, push it off to the side, and just press down on it.
Is it supposed to be doing this?
Yeah.
It's freezing.
Do that again.
That's weird.
Isn't that weird? Maybe take a piece and put it inside the spoon.
It's moving. It's supposed to.
It's moving?
It's making a weird noise and moving if you can't see it in the back.
It's like a joy buzzer.
Can you hear that? It's like a joy buzzer. Okay.
So, does anyone know what the dry ice is actually doing to this here? You in the back. Oh, fancy word, sublimating. So that's actually a nice word for it's boiling without turning into a liquid. It's just going straight to the gas phase. So there's actually a lot of energy being released, and what the spoon is doing, the spoon is actually absorbing it. And because the spoon is made of metal and it's so rigid, it's trying to bend. And in it trying to bend while the carbon dioxide is boiling, it's actually making these really cool noises. And the reason the dry ice is trying to run away is because it's boiling. It doesn't want to stay in one place.
Awesome. Thanks,
Very
girls.
cool.
You want to keep doing that for a minute? We're going to set up this next activity here. Okay, now notice I have a thing of hot water over here. All right, that's cool. Go ahead and take all of that dry ice and throw it in there.
Hocus pocus.
Oh yeah, okay. We're going to do this. If you noticed, your spoons are pretty cold, right? But they're going to warm up quickly because metals are really good at conducting things like heat. Okay? So let's take these and we'll bring them over here. Let's take that. Okay. Now I've got this very special solution in here. This is bubble solution.
Okay.
Okay. And so now I've got this strip of fabric. What we're going to try to do is we're going to try to make a giant bubble that looks like a crystal ball, okay?
Should I step back?
No, you don't have to step back.
Okay.
You know what, I'm going to scoot this over just a little bit. Okay. Okay. And I'm going to have you guys try this as well. You can take your gloves off if you want. So here's what we do. We're going to hold it tight. We're going to start it at this end and gently pull it towards you. And hopefully the soap film will stay on there. Oh, it broke. Did you see how it broke?
Probably because I breathed it.
Did you breathe on it? It takes a little bit of practice, a little bit of luck, but sometimes you can get it to work. Like that. Okay. Now, if we were at Hogwarts and we had our magic wands, we could say Wingardium Leviosa, right? Wingardium Leviosa. So it sort of looks like a crystal ball, right? So you can see into the future. I see you all sleeping in tomorrow and not getting up in the morning to come to school. That's what I see. And then you can maybe blow it a little bit. Want to go ahead and touch it? Can you touch it? Oh, all right.
Bro, it's cold.
Is it cold? It shouldn't be that cold because the water's pretty warm. Do you want to try to do it yourself?
You can do it.
You want me to do it again? Okay.
So what Dr. Polymer is doing, if you notice, he's actually putting a layer of soap film over our carbon dioxide smoke screen. And we're actually trapping it in the bowl, and because the gas is expanding, it's making this really cool crystal ball effect. And even though it's still really cold, we have to remember that it's actually still boiling. It's just boiling at a really cold temperature, right? So normally when we're at home and we're making tea or coffee, right, we're used to something boiling at about 100 degrees. But water boils at 100 degrees. Carbon dioxide actually boils at less than 100 degrees, minus 100 degrees.
So I think our carbon dioxide is slowing down a little bit. If you guys were observant, you noticed that I had to put more dry ice into these containers to keep it bubbling. But this one seems to be slowing down a little bit. It's growing.
So who knows what's the sure way to know if something is boiling? I will ask someone over there in the black t-shirt. Yes. Bubbles, that's right. So if you ever wonder if something is boiling, right, if you don't want to touch it, just look at it. If it's making bubbles, it's a good chance that it's boiling.
All right, we'll do this one more time. Get a couple more pieces in there. Is our water still warm? Yep.
More.
Okay. Pull that out. All right. Now wait. Did you want to try? Yeah. Okay. It's fun. All you do is you pull it across toward you. Not super fast, not super slow. Keep it tight. There you go. See the bubble forming?
Oh, very cool.
There we go. Okay, let's give a round of applause for these ladies. Thank you, girls. If you could just drop your glasses, that'd be good. Alrighty. Okay, while we're waiting for that to go up, we're going to get a couple more volunteers up here. Blue shirt, come on up. Yep. And Cleveland Browns, come on. Okay, so you're wearing regular glasses. I'm going to say you're not going to need your safety glasses, but I'd like for you to put those on, please. Okay. Alrighty. So, you know what this is? Do you know what that is? You guys are showing your age. Okay, for the older people in the room, you probably recognize these, right, grown-ups? Okay.
There was a time.
These are just called, these are film cans, and they actually used to, when you used to have a camera to take pictures, what you'd have to do is put a thing of film in it, and then you'd have to take the film out and take it to the store to get it processed. There was no such thing as just being able to see your picture right after you took it, okay? So I'm trying to get a little bit of this warm water in here. Now what we can do, the film cans are really good at, they're really good at keeping things sealed. So it's like a sealed container, all right? What we're gonna try to do with the film cans is we've got some water in there, we're gonna stick a little piece of dry ice in there, and then we're gonna seal it up real quick and see what happens, okay? Are you ready? Are you sure? Okay, ready? Let's always practice safety. So as soon as I drop it in, you cap it up, okay? Make sure you get a good seal on there.
Oh, that almost got me.
Hey, all right.
There we go.
Good job, guys. All right, thank you. Get the glasses. And this substance is called liquid nitrogen. So we have to be very, very, very careful when we're dealing with liquid nitrogen, and we have a special container for it as well. Okay. So this is called a Dewar flask, and it's very, very good at insulating things. Okay. It is made. There's actually the inside of it is made out of glass, and then there's an area between. Okay, so there's a gap in between. So there's a glass area, and then there's a gap in between, and that gap is, they take the air out of it, so it's called a vacuum, okay? Because it's such a vacuum, it's really good at insulating, okay? You can't get heat traveling through there. And then the other thing that's interesting about liquid nitrogen is it's super cold. So notice, this is not a screw lid, it just lifts up and off, okay? Because inside of here, if this were to warm up very quickly, it would blow the lid off, okay? So we wouldn't want this to be, to expand too quickly, and just in case it did, this would be able to come off nice and easy, all right? Okay, so liquid nitrogen is fun, again, but it can also be fairly dangerous. So you have to be very careful and exercise good lab safety when you're working with it. So what I'm gonna do right now is I'm gonna pour some liquid nitrogen into this container. I think I'm gonna have to do it behind the table, okay? And then we got lots of cool things to do with it.
So while Dr. Polymer is pouring, I had a quick question. Who knows the states of matter? Oh wow, lots of people. I will pick you right there. Solid, liquid, and gas, right? And to turn something from a liquid to a gas, what do you do with it? Black t-shirt right there. Yes, you. Yep. You heat it up, right? Oh, you know about plasma. They know about plasma. So there are actually 4 states of matter. So plasma is one of them. So for a liquid nitrogen, that's a liquid at minus 200 degrees Celsius, right? For it to turn into a gas, it has to go past minus 200 degrees Celsius. What temperature is it in this room? In the coat right there. Someone said, how do we even know? That's actually a good question too. Do you think it's minus 200 degrees Celsius? No. Do you think it's closer to about 20, 30 degrees? All right? So if we have liquid nitrogen at 20 degrees Celsius, what is it doing?
Somebody say boiling.
Boiling. That's right. It's boiling, right? So we have something that's really cold that's boiling. Sounds almost counterintuitive, but yes, it actually is boiling. So don't think it's hot. It's actually really, really, really cold.
So what's interesting about this is that anything that's at room temperature will cause it to boil, okay? So notice I have this rubber tubing here, and if I stick one end into the tube, into the nitrogen, we should see something happen there. Can you see that? I'm shooting it out, okay? But then, if you know about anything about what things happen, what happens to things when they get cold, okay? See that? It's no this part was not in the nitrogen, but this part was. So I can't quite break it. But at any rate, let's get some of that out of here. Okay, so that's what it looks like. Okay, so the beaker is warm enough that it's causing the liquid to boil. Okay, now let's try that one more time if you can see it a little bit better. See it coming out? I don't know if you can see it. Okay, and if I leave this in the beaker long enough, what I should be able to do is take it out and wrap it on the side of the table, and it should shatter. Okay, that's the goal. We want to see it break. Okay. No. Oh yeah, so it broke. Okay. And then once it warms back up, it's going to be flexible again. Okay. Let's see here. We got lots to do with the liquid nitrogen, and so maybe we should start with this. If we want to take our little experiment with the film cans and sort of make it a little bit bigger, okay? So I'm going to put some liquid nitrogen in here. So the gas or the liquid itself, it's going to expand as it warms up. All right.
Oh, wow.
That was pretty fun. All right, let's put this back in as well. Okay.
So I had a quick question for the audience. Why do these things keep popping open? Does anybody know why? Like in the hoodie right here. It can't get out, right? But if we notice, right, our first thing was a solid and our second thing was a liquid. So what happened in the red? That's right, and it turned into a gas. And what happens when you try to keep a gas contained? Oh, I just heard a word that starts with the letter P. What was that word? Pressure, right. We build up pressure. And if the container can't handle the pressure, what happens?
Pop! That's what we did.
Right.
Okay. All right, well, so over here, let's get some of these things out of the way. Let me show you this. We have a tray full of soapy water. Now remember, the water is a lot warmer than the nitrogen. So what do you think will happen if I pour some liquid nitrogen into that water? What do you think? Right there, go ahead. It's going to evaporate? Well, what happens when you have soapy water in the sink at home? Bubbles, yeah. And I think, I don't know, we might have too much water. I don't think we're going to make frozen bubbles, but we might be able to make something that's cool. Whoa.
Oh, wow.
They're definitely not frozen, are they? No, they're not. It's kind of messy. That's a little fun. Okay. Okay, let's see here. Oh, yeah, I was going to freeze a banana. That's right. Okay. Freeze a banana, and then you guys, everybody knows what this is, right? So you know what that is. You think that I could use this, maybe this, instead of this? What do you think? On these? I don't know. All right, well, let's freeze that banana. All right, I think we might be ready to smack something with our banana. Okay? So that you never knew that you could use a banana as a hammer, did you? Let's see. Okay. Uh-oh. Oh no, it just broke. It may work and it may not work because it looks like it cracked a little bit. Let's see. Okay, ready for this? On three. 1, 2, 3. Oh. No, it's not gonna work. I've done this before though. Here, wait. Let's do this. I'm gonna do this instead.
Oh, frozen banana.
That was slightly messy. All right. We got one more thing to do, okay? But this doesn't require any volunteers, okay? We're actually going to do it over where that bucket is over there, okay? And the last one, this is called our thundercloud demo. And Coach Cruz wanted me to see if I could get it to snow inside the room. So that's what we're going to try to do today. We're going to try to make it snow, okay? All right, so I don't know if you can see what this is, this white powder. It's called instant snow. And we're going to add that to the container of liquid nitrogen, okay? Hopefully it's not going to get too hot. Okay. Now instant snow, when you add water to it, it gets all big and fluffy, all right? And we have a container of instant snow behind me that's already been hydrated. So when you add water to instant snow, it looks like this, okay? So what we're going to do is we're going to take this container of liquid nitrogen with instant snow, we're going to set it over there, then we're going to dump a bunch of hot water in it. See what happens. It's called thundercloud, okay? I don't need any volunteers for this, all right? This one's too dangerous.
You're gonna pour it
I
into
think
the
this
bucket?
might be too much. All right, you guys ready? I don't know. I think you might be too close. All right. So we're going to go 3, 2, 1, and I'll dump it in, all right? You ready for this? Okay, let's have that countdown. 3. Oh my goodness.
You made a heart.